Hello, welcome to our channel for probability and statistics. In this video, we will talk about hypothesis testing on a single proportion. So very often, people are interested in the population proportion for a specific characteristic. So in this case, the problem can be formulated as a hypothesis testing of proportion in population. So we can formulate as H0, so null hypothesis that the proportion is P0. And this P can be seen as the success rate in a binomial distribution. And the alternative hypothesis, if for one side is P less than P0 or P larger than P0, but not both. If for two-sided alternatives H1, so the hypothesis is P not equal to P0. So if either of these occurs, we will in favor of H1. So if we look at this problem, it's a binomial distribution. So the appropriate random variable in the sample binomial X success events, if this number is very far from the sample size times P0. P0 is the hypothesis, the population proportion. So if this sample success number is very far from the hypothesis success number mu, then we will reject the population proportion equals P0, right? And binomial probabilities can be obtained from the binomial formula or from the table when the sample size is small. But in the larger sample, we can use approximation. So there are two cases. If P0, if we know the population proportion is very close to 0 or 1, so it's a very extremely large proportion or very extremely small proportion. So in this case, we have to use a Poisson distribution with the parameter mean number is n times P0. But very often, if this proportion, hypothesis the proportion is not very close to 0 or 1, also in a larger sample, so sample size larger than at least 30, so we can use normal distribution approximation because normal distribution is mostly widely used distribution and it's bell-shaped. So it's very idealized that we can use normal approximation for the proportion. So we can formulate a Z value which equals the sample success number times the hypothesis the proportion times the sample size and divided by the square root of sample size times hypothesis the proportion times 1 minus this proportion. So after mathematical manipulation, we can get this Z value equals the sample proportion times the population hypothesis the proportion, then divided by the square root of hypothesis the proportion times 1 minus this proportion divided by the sample size. So this is exactly the Z value for the normal test. And it's very easy to get the critical value if we know the level of significance alpha. For example, alpha is 0.05. So for the critical region, will be say less than about 1.96 minus 1.96 or say larger than 1.96 for the two-tailed test. For the one-sided test is about 0.05. This critical value will be 1.645. So either say less than minus 1.645 or say larger than 1.645, then the test will be significant. So we will reject the null hypothesis, or we will reject that the population proportion will be equal to P0. So next we take a look at an example. A commonly prescribed drug for relieving nervous tension is believed to be only 60% effective. So this is 60% is for the population proportion, right? Then experimental results with a new drug are administered to a random sample of 100 adults who were suffering from nervous tension show that 70 received the relief. So this is the sample size and 70 success, right? So is this sufficient evidence to conclude that the new drug is superior to the one commonly prescribed, use 0.05 level of significance? So in this problem, very clear, H0 null hypothesis is proportion equals 0.6. This is what we want to test. And alternative hypothesis H1, from the problem description, this is a one-sided test because we exclude the case that the new test is lower than 0.6. So this we exclude this case. So we only think about if the new test method is better than the current one. So we formulate H1 is a one-sided hypothesis, one-sided test. This is if P larger than 0.6. Then we get alpha level 0.05 and get the critical region for normal distribution for one-sided. So this critical value level is 1.645 for normal distribution. Probability 0.05 if say larger than this value, right? So next we can calculate the z value from the sample. So this test statistic, we just fill in all the information. This is the sample proportion. This is the hypothesis population proportion we want to test. And square root of this proportion times 1 minus this proportion. So 0.6, 0.4, then divided by the square root, that's divided by the sample size. So all three parts take a square root. So we get, say, is 2.004. So you can see this say value larger than this critical value, right? And also we can get the p-value is 0.02. So the test is clearly significant at significance level 0.05. So we can get a conclusion that we will reject H0 and conclude that the new drug is superior. Thanks for watching.